What's up guys, this is Massey. Welcome to another video. In this video I want to talk about rate laws. If we again going back to the reaction we had earlier, which is the decomposition of nitrogen dioxide, 2NO2 gives us 2NO plus O2. The reaction rate will depend on the concentration of the reactant. So the rate of reaction is going to be equal to K times NO2 to the power of N. It means that K times the molar concentration of NO2 to the power of N. That expression, which shows how the rate depends on the concentration of reactant, is called a rate law. So this one is the rate expression, and that's called rate law. As you see here, we see the K, we see the N, and we see the concentration of the reactant. The proportionality constant K is called rate constant. So this K is called rate constant, and it is constant at a specific temperature, and it is changing with different temperature. If we increase the temperature, K value is increasing. If we reduce the temperature, K value is reducing. But K, the value of K is not changing with the concentration, so that's why it's called rate constant. And N, as you see here, exponent, is called the order of the reactant. Order of the reactant is N, and both of them, both K and N, must be determined by experiment. So they are we found them experimentally. The order of the reactant can be integer, including 0 or a fraction. So N can be 0, 1, 2, 3, or half, or something like that. Two important points I need to mention. First of all, the concentration of the product do not appear in the rate law because the reaction rate is being studied under the condition where reverse reaction doesn't contribute to the overall rate. So it means that the rate law is only depending on the concentration of the reactants. And the second one, it says the value of the exponent N must be determined by experiment, and it cannot be written from the balanced equation. So basically it means that when we have the balanced reaction, we cannot say N is 1 or 2 or 3. We need to find it experimentally. So let's say an example here. 2NO2 gives us 2NO plus O2. The rate of reaction of NO2 is going to be changing the concentration of NO2 over time, and it's going to be equal to K times the concentration of NO2 to the power of N. On the other hand, we have rate star, which is going to be the changing concentration of O2. As you see here, it is positive. Why? Because it is a product and it is increasing, so that's why it's positive. It's going to be equal to K prime times NO2 to the power of N. And we had it earlier in reaction rate that the reaction rate of NO2 divided by 2 must be equal to RO2, the reaction rate of oxygen. Why divided by 2? Because the coefficient of NO2 is 2 in here. So it means that rate equals to 2 times rate star, or K NO2 to the power of N equals to 2 times K prime times NO2 to the power of N. It means that K equals to 2 times K prime. Now let's see how to find out this N and K. We need to, one of the methods that we can find N and K is called initial rate. One common method for experimentally determine the form of the rate law for a reaction is the method of initial rates. Initial rate of the reaction is the instantaneous rate determined just after the reaction begins, just after T equals to 0. It means that we consider the concentration being as initial concentration. The idea is to determine the instantaneous rate before the initial concentration of reactant have changed significantly. So we assume that the concentration equals to the initial concentration. Several experiments are carried out using different initial concentrations, and the initial rate is determined for each run. And the results are compared in order to find out the value of N and the value of K. Let's see an example. Here in this example, we want to find out the rate law. It says the reaction between bromate ions and bromide ion in an acidic aqueous solution is given by this equation. Bromate ion plus 5 Br plus 6 hydrogen over 6 proton gives us 3 Br2 plus 3 water molecule. Determine the orders for all three reactants, the overall reaction order, and the value of the rate constant. It means that we need to find out the order of the reaction and also the value of K. So if we write the general form of rate law for these three reactants, I need to write it this way. Rate equals to K times the concentration of bromate to the power of N, the concentration of bromide to the power of M, the concentration of proton to the power of, let's say, O. Or let's call it P, because it might give you an impression that it's initial concentration. So we have 4 different runs. Let's say if we want to find out the ratio of rate 2 over rate 1, then we can say we have K times the concentration of bromate in the second run is 0.2 to the power of N times bromide is 0.1 to the power of M times the concentration of proton is 0.1 to the power of P divided by K times the first run is 0.1 to the power of N times 0.1 to the power of M times 0.1 to the power of P. Now what we can say the rate of reaction is for the second one is 1.6 times 10 to the power of negative 3, and for the first one is 8 times 10 to the power of negative 4, which will be equal to 2. Now let's simplify this expression. K and K is not changing with concentration, so they are equal, so they cancel out. 0.1 to the power of P over 0.1 to the power of P, they cancel out, they are the same. 0.1 to the power of M divided by 0.1 to the power of M, they cancel out as well. And here we have 0.2 to the power of N divided by 0.1 to the power of N. When you simplify it, it's going to be 2 to the power of N equals to 2. So N will be equal to 1. So that's the order of bromate. Now let's find out the order of the second reactant. So I'm going to say R3 over R2. If you compare this R3 and R2, run 2 and run 3, the concentration of proton are the same, the concentration of bromates are the same, but the concentration of bromide is different, so we can find out the exponent. R3 over R2 is 3.2 times 10 to the power of negative 3 divided by 1.6 times 10 to the power of negative 3, which is going to be equal to 2 times K times 0.2 to the power of M, N, 0.2 to the power of M, 0.1 to the power of P, divided by K times 0.2 to the power of N, 0.1 to the power of M, 0.1 to the power of P. Then you can say that these two are the same, cancel out, K's are the same, and this part is the same as well. So we're going to have 2 to the power of M equal to 2. It means that M is also equals to 1. So the order of reaction with respect to bromide is 1 as well. Now let's consider number 4 and number 1. Compare these two. The concentration of bromate are the same, the concentration of bromide are the same, but the concentration of proton is double. So run 4 over run 1 equals to 3.2 times 10 to the power of negative 3 over 8 times 10 to the power of negative 4. That's going to be equal to 4. That has to be k 0.1 to the power of n, 0.1 to the power of m, 0.2 to the power of p, divided by k times 0.1 to the power of n, 0.1 to the power of m, 0.1 to the power of p. That's going to be cancel out, these two cancel out. 0.2 divided by 0.1 is 2. So 2 to the power of p equals to 4. So p will be equal to 2. So the order of reaction with respect to proton is 2. So far we have rate equals to k times bromate to the power of 1, bromide to the power of 1, and proton to the power of 2. Or you can say k times bromate, bromide, proton to the power of 2. Now we know the overall rate of reaction is going to be, the overall order of reaction is going to be 2 plus 1 plus 1, which is going to be 4. So the overall order of this reaction is 4. Now the only missing part is k. We need to find out the value of k. So if we want to find out the value of k, we can use any of these 4 experiments. So let's choose one of them. I don't know, let's choose the first one. It looks easier. 0.1, 0.1, 0.1, and this one is 8 times 10 to the power of negative 4. So that's going to be 8 times 10 to the power of negative 4 equals to k 0.1 times 0.1 times 0.1 to the power of 2, which is going to be 8 times 10 to the power of negative 4 times k times 10 to the power of negative 4. It means that k is 8. What is the unit for k? We know the unit for R is the rate of reaction, mole per liter per second. Here we have mole per liter, mole per liter, mole per liter squared, because we have to the power of 2. So that's going to be mole per liter per second, k mole to the power of 4 divided by liter to the power of 4. So k will be mole per liter per second divided by mole to the power of 4 liter to the power of 4. That's gonna be liter cube over mole cube times second. So that's gonna be the unit of k, and the value of it we already found it here, 8, which is 8 liter cube divided by mole cube second. That's the unit for k. So we found that the rate constant and order of the reaction. Let's see another example. The reaction 2NO plus Cl2 gives 2NoCl was studied at negative 10 degrees Celsius. The following results were obtained. So these are the initial concentration of each of them, and these are the initial rates. That's run 1, run 2, run 3. It asks us what is the rate law and what is the value of the rate constant. So it's going to be very similar to the previous one. I'm going to say run 2 divided by run 1 equals to 0.36 divided by 0.18, which is going to be equal to 2. So we have k times 0.1 to the power of m times 0.2 to the power of n divided by k 0.1 to the power of m times 0.1 to the power of n. The overall reaction is defined as NO to the power of m times Cl2 to the power of n. So that's why we have 0.1, 0.2 in the numerator, 0.1, 0.1 in the denominator. So now, as you see here, again, we can cancel k's because k is changing only with temperature. These two are the same. We have 0.2 to the power of n divided by 0.1 to the power of n, which is going to be 2 to the power of n. So 2 equals to 2 to the power of n it means that n equals to 1. Now, let's see how to find out the value of m. So I'm gonna say run 3 over run 2, which is gonna be 1.45 divided by 0.36, which will give me 4.02, or approximately 4. That's equal to k 0.2 to the power of m 0.2 to the power of n divided by k 0.1 to the power of m 0.2 to the power of n. Again, k's are the same, cancel out. These two cancel out. 0.2 divided by 0.1 is 2. 2 to the power of m equals to 4. So the value of m is going to be 2. Why? Because 2 to the power of 2 is 4. So the rate is going to be k and o to the power of 2 times CL2 to the power of 1, which I don't need to write it. Now we need to find out the value of k. We can use any of these 3 runs. I'm gonna choose the first one, 0.1, 0.1, and 0.18. So it's gonna be 0.18 k 0.1 to the power of 2 times 0.1. So k will be 0.18 divided by 0.001. So that's gonna be 180, and the unit will be liters squared per mole square second. Because this one is mole per liter per second, this one is mole per liter to the power of 2, this one is mole per liter. So k will be liters squared over mole squared times second. Next example. This example, it says the reaction of 2 iodide plus S2O8 2- gives us I2 plus 2 sulfate. Was studied at 25 degrees Celsius. The following results were obtained. So we have 5 different runs. We need to determine the rate law, and we need to calculate the value of the rate constant. Okay, so we don't need this many reaction rates with this many runs. We just need 2 of them because we have 2 reactants. So I'm gonna say, let's say run 2 over run 1, because if you compare run 1 and run 2, the concentration of this part is constant, but this one is changing. So I'm gonna say 6.25 times 10 to the power of negative 6 over 12.5 times 10 to the power of negative 6 equals to k to the power of m S2O8 2- to the power of n over k. Same thing. In the first one, the concentration is going to be 0.04, here 0.04. In the second one, we have the run number 1, 0.08 and 0.04. These two k's cancel out like the previous example. These two also cancels out. We're going to have 6.25 times 10 to the power of negative 6 divided by 12.5 times 10 to the power of negative 6 will be 1 over 2, or 2 to the power of negative 1. And here we have 0.04 divided by 0.08 is going to be 1 over 2 to the power of m, which means that m is 1. Now we need to find out the order of the other reactant, which is this one. If I compare run 1 and run 3, I can say run 3 over run 1, which is going to be 6.25 times 10 to the power of negative 6 to 12.5 times 10 to the power of negative 6, which will be k 0.08 to the power of m times 0.02 to the power of n divided by k 0.08 to the power of m times 0.04 to the power of n. This divided by this is going to be 1 over 2, and here these two cancels out. K's. This part is going to cancel out. 0.02 divided by 0.04 is going to be 1 over 2 power of n. So n is 1 as well. So the order of reaction with respect to each of these reactants is 1, and the overall rate of reaction is 2. The overall order of reaction. So R equals to K times iodide to the power of 1 times S2O8 2 minus to the power of 1. So we have, for finding K, we can sub any of these numbers for each run. So we choose just one of them. I can say the first one, 12.5 times 10 to the power of negative 6 equals to K times 0.08, 0.04. That's going to give me K equals to 3.9 times 10 to the power of negative 3 liter per mole per second. So depending on the order of reaction, the unit of K is changing. So you need to be very careful that the unit for K is different from one question to another question. It really depends on the unit of the rate of reaction, and also depends on the order of reaction. Let's see another example. So in this example, we have the decomposition of nitrosyl chloride studied. 2NOCl gives us 2NO plus Cl2. So we have one reactant. So the initial rate depends only the initial concentration of one of the chemicals, which is NOCl. So what is the rate law, and calculate the rate constant? We're going to say the general formula rate equals to K times NOCl to the power of n. So what we can do, we can find out the ratio of these guys. It depends on how we arrange it. Doesn't really matter which two we select. Let's say have run 2 over run 3. 2.66 times 10 to the power of 4 divided by 6.64 times 10 to the power of 3 equals to NOCl to the power of n, which is 2 times 10 to the power of 16 to the power of n, divided by 1 times 10 to the power of 16 to the power of n. And the unit is molecules per cubic centimeter, and the initial rate unit is molecules per cubic centimeter times per second. So 2 times 10 to the power of 16 divided by 1 times 10 to the power of 16 is going to be 2. So 2 to the power of n equals to this part, which is 26.64. That's going to be around approximately 4. So n will be 2, because 2 to the power of 2 is 4. So R equals to K times initial concentration of NOCl to the power of 2. If we want to find out the K, we can use any of these rate law. Let's choose the third one, for example. The rate is 6.64 times 10 to the power of 3 equals to K times 1 times 10 to the power of 16 to the power of 2. If we do it this way, the answer will be K equals to 6.64 times 10 to the power of negative 29. And the unit will be centimeter cube or cubic centimeter per molecules per second. Why? Because this one is rate is molecules per cubic centimeter in second. K molecules divided by cubic centimeter to the power of 2. So if we divide it, K will be cubic centimeter over molecules per second. I hope you enjoyed this video. Please leave me a comment if you have any question. Please don't forget to subscribe this channel. You can have access to many other videos regarding chemistry, physics, and math. Thank you for watching and have a great day.